Hello, class, and welcome to the final week in our class and the final lecture. This week's lecture is going to be on threat modeling and attack trees, testing, both pre-production and post-production testing, as well as digging a little bit deeper into audits. The material in this week's lecture is from the one of the chapters you were supposed to read in week 1. It's Chapter 2, Risk Management, from the book Enterprise Security, A Practitioner's Guide. Threat modeling requires that you have a baseline, and the baseline is created every time that you do a risk assessment on a single system or network segment. And this baseline provides us with a list of existing vulnerabilities, controls, and business impact associated with a specific system or network component being compromised. All of this information is necessary to correctly assess the ability of a threat agent to make it along a path through controls undetected to reach its objectives and to achieve its final objectives. So as you can see here, threat modeling consists of an assessment phase where we break down the systems, looking at exit points, entry points, data channels, and untrusted data items. We identify threats and vulnerabilities, create our threat and vulnerability pairs. We look at attack path controls. We look at controls that follow the attack paths that we actually use in the risk assessment process. We do an impact analysis, understanding what the business impact is if a threat agent is able to reach its objectives or achieve its objectives. And then we look at the risk associated with all of those things. And the control recommendations lead to mitigation. We put together an action plan and mitigate we add new controls, or we reconfigure existing controls, or implement existing controls in different ways. And then we manage by measuring and adjusting. So the risk assessment step that we should be following or executing on a regular basis on all critical systems or systems that process sensitive data, and on network segments that contain those systems, they continuously provide us the information we need to construct and follow attack trees. So an attack tree traces a probable attack path for a threat, either a new or an existing threat. And we need to pause here for a second, because not all emerging threats pose a high risk to your business. That's the purpose, one of the purposes of attack trees. When an emerging threat is announced, you simply sit down with an attack tree, and as you build attack trees, you go ahead and file them away, because you can always pull out attack trees that pertain to your critical systems whenever an emerging threat arises, and then follow the intended attack path for that emerging threat and do a risk assessment and assess the risk of that new emerging threat. I can tell you from experience that most emerging threats, if you've properly configured your network and you followed best practice and you've got your monitoring and response all put together and practiced, and everybody knows what they're supposed to be doing, you have policies in place, you have consistently followed procedures, that the vast majority of emerging threats are not critical to your business. So for example, when Microsoft releases patches on Patch Tuesday, in many cases, several of them are going to be critical. That is critical if you haven't really done anything to protect your network. Microsoft's just covering their own selves. What you have to do is sit down and determine what each of those vulnerabilities and the associated threats mean to your business, based on your security program, your security context. And attack trees are extremely useful in doing this. and that's why it's important to understand them. Also, when developing software, it's important to be able to use attack trees to determine whether or not an attacker would be able to compromise the software in any way. So when you build an attack tree, you're checking for existing vulnerabilities along the path that pair with the threat agent under assessment. You determine risk, and we learned to do that in week 1. We design controls or processes to reduce the risk if necessary, and we apply those controls and processes, and then we go back. And actually, before we apply the controls and processes, we should go back and verify that with a new attack tree analysis, that what we're proposing will in fact lower the risk of compromise. This is an example attack tree. In this particular example, the target is a database server, and in that database server are customer records. We have identified 2 paths to arrive at that target. We have a remote path and a local attacker path. There could be many more, and for each attack path you can think of, it goes on this, or you could have multiples. But as you're going to see as we work through this, if you put them all on here, it gives a better view of your risk, and it gives a better understanding of what controls you might need to put in place to mitigate that risk. Also, as we move up the attack path, so for example, the attack path for a remote attacker is through the internet firewall, web server, and external firewall to the enterprise switch, and then into either the operating system configuration or the database configuration to get to the target data in the database. Along that path, all we have to do is mitigate the probability of breach or bypass for 1 or 2 of those critical components, and we can significantly reduce the probability of success for the attacker. It isn't necessary to do everything, and as we'll also see as we go through this, it's often possible to do something that costs absolutely nothing to significantly reduce risk down to levels acceptable by management. So on the first layer for the remote attacker, we have her facing an internal firewall, a web server, and an external firewall. The firewalls both have been configured for wide open and only blocking what the security team thinks might be malicious. This is just the opposite of what we've talked about for firewalls. Firewalls should be implemented to block everything and only allow things that are absolutely essential for business operation. The P equals 1 in the firewall boxes is probability. 1 is 100%. So what this demonstrates is that because they're wide open and this particular threat is not blocked, there's a 100% probability that this threat or threats like it can bypass both of the firewalls. The web server has, and as we'll see as we go into a future slide, the web server was calculated as having some problems. For example, it has a vulnerability that can enable a threat agent or a remote attacker in her quest to breach the web server and get access to the target, the internal network. So each of these components, the internal firewall, the web server, and the external firewall, each of them has had an attack tree completed on it individually. That's how we arrive at these probability values. Now, in probability, if you have an and that and in red is a Boolean and, which means all of the inputs must be true for the output to be true. So in this case, an attacker must be able to breach or circumvent all 3 of those boxes, the internal firewall, the web server, and the external firewall, to be able to gain access to the enterprise switch. In probability theory, when you have multiple things that must be true, you multiply them together. In this case, if we multiply them together, we have 100%, 50%, and 100%, we end up with a 50%. So we have 50% going up to the enterprise switch, 50% chance that a remote attacker can bypass the DMZ consisting of these two firewalls and the web server and get to the enterprise switch. If we remove the web server from the equation and we only had to get through the two firewalls, the attacker would have 100% probability of getting to the enterprise switch. One of the biggest problems here in the firewalls is that port 1433 is open, which is the default port for Microsoft SQL Server. For the local attacker, we've assessed physical access, and we found that gaining physical access there's a 50% probability that anyone can do it, even if you don't use a lot of social engineering skills. There's also a 100% chance that an attacker gaining access would be able to find an open port, because this particular organization does not shut off unused ports or connect them to unused VLANs. So gaining access to an open port in a conference room or at a desk, an empty desk, is very easy to do. So there's a 50% chance that the user would be able to, that a local attacker would be able to access the switch and gain access to the internal, and therefore gain access to the server. So as you notice, there's an OR going into the enterprise switch. For ORs and probability, we add. So if one or the other could have to be true to get a true out, or one or the other have to be compromised to get to our target. In this case, either the remote attacker gets through or the local attacker gets through. And there's a 50% chance of each of those happening. We add those two together, and there's a probability of 100% of someone getting to the enterprise switch. Once we hit the enterprise switch, there's a 100% probability of getting to the network. And the reason for that, or to the server, and the reason for that is because the database network is not segmented. Once you have access to the enterprise or core switch, you have access to all devices in the data center. So once you get to the switch, there's a 100% possibility to get to the server. Once you arrive at the server, you can either get to the target data through the operating system and just copy the whole database off and take it home with you, or you can go through the database config and just copy the data. The database config primarily being the security configuration. Based on attack trees we did on the OS and an attack tree we did on the database configuration, we see that there's a probability of 60% that an attacker would be able to get through either one of those. Now remember, we determined that when there's an OR, we add. In this particular case, it comes out to 1.2, 120%. That's the extra 20% is irrelevant. What that we end up with is 100% possibility of getting to the target data. And this particular attack tree, remember, this is just probabilities. And this and also one of the other things I didn't mention, this particular organization has no monitoring and no log management processes to check for anomalous behavior. Because if it did, then these probabilities would change significantly. In this particular network, we can say with certainty that, with almost complete certainty, that a breach is possible, and all the attacker needs is a little motivation, a little skills, and the game is over. So here's an example of the web server attack tree, a component attack tree. Notice that we had a relevant IIS vulnerability that was paired to the threat, and it existed because they hadn't patched the server. Sufficient attacker motivation. If the attacker gets access to the data, it has value, so the attacker is motivated to get to it. And sufficient attacker skills. because we do have some controls in place, we believe that there's a 50% chance that the attacker hitting the network would have sufficient skills to circumvent the web server. The fact that the act is undetected is 100%. And because we have 50%, so because the first level and the second level have to be true, we go to the server at 50% probability that an attacker could compromise the web server. This is another way to build an attack tree. This is what I call an on-off attack tree, something that has been written about by Bruce Schneier. And this is much simpler than using probability. However, it assumes that things will either happen or they won't happen. There are no shades of gray. And I don't believe in black and white when it comes to security. There are always some gradations of gray between what's possible and what's not possible. But if you're looking at a target that is not highly critical, where the data is classified lower than the highest level, maybe this is the right thing to do. For applications, this can be very useful. The attacker can leverage these particular components to reach an objective, or they can't. So for applications, this might be more useful than a probability attack tree. So what we see here is that we have an AND again, and now in a Boolean AND, all the inputs have to be 1 to get a 1 out. In our case, a 1 is yes. So does a relevant IIS vulnerability exist on the web server? So obviously this web server has been modified. We have applied the patch. So no, it does not exist. Is there sufficient attacker motivation? Yes. Sufficient attack skills? Yes. Well, because the vulnerability no longer exists, it doesn't matter about attacker motivation, and it doesn't matter about attack skills because there's nothing for them to exploit. So 0 plus and 1 is 0. Remember, all the inputs have to be 1 to get a 1 out or an on or a yes. In this case, we get a 0 or a no. It goes and is ANDed to act undetected. The organization still does not have log management in place. So the 0 is ANDed to the 1, and because you have to have 2 1s to get a 1 out, we get a 0 out, which is no. So remember, 1 is yes, 0 is no in our example, which means that based on this on-off approach, there is no chance that an attacker can circumvent the web server using the specific threat that is paired with the vulnerability that we have shut off. Now we're going to go into software testing. There are 4 types of testing, 3 that are pre-production and 1 that is post-production. The first one is unit testing. Unit testing is done by developers. When I was programming, and this will age me, but we didn't really use object-oriented programming. We used procedure, but we did write modules. So it was very structured. So every time I would write a module, I would test it and make sure that the inputs that the module received always produced the expected outputs. And if I threw a bunch of garbage at the inputs, I would either send an error. I would either produce an error message, or I would send back a value that informed the application or the user that something bad had occurred. However, anything that would have been insecure would have thrown an error message. Buddy checking is taking that same module or object that I was just talking about and having another developer test it for you. Testing your own software is not usually a good idea. Most of us are locked into testing only what we expected the function or the object to do. You give it to another programmer, they're not really vested in what you've done, and they can beat on it until it breaks if it is brittle enough to do so. Quality assurance. Once the unit testing is done and the application is deemed ready by development, it goes to a QA group. They create formal test plans based on functional and technical requirements, including security, and they test against those requirements. Many QA departments do not do technical testing. In other words, testing against the operating system and the platform in which the application will run. When that isn't done, the engineers can do it at this point, or it can be part of the post-implementation check. Once QA is satisfied with it, it goes to the user acceptance testing. User acceptance is completed by the actual business users who will use the application. They are going to verify that they're getting what they expected. At any point along here, the application can be bounced back to developers for modifications. If it does that, then it starts again and goes through the process all over again. The post-implementation check happens after the system goes into production, and it verifies that all technical requirements, including security, were met. The users have already accepted it, and then they will also check in as part of post-implementation, but mostly it's just to make sure that the system is up and running and they can access it. From a technical perspective, post-implementation check is to make sure that all the vulnerabilities that we believe were supposed to be gone and access controls, both in the application, on the application's host server, and along the attack path leading to the application, are all working as we expected them to work. Also, before a system goes into production, either during or after user acceptance testing, and I would always do it before user acceptance testing, and that is if it's a Microsoft system, Microsoft operating system, I would run Microsoft's Baseline Security Analyzer, MBSA, and ensure that all the vulnerabilities that we expected to be blocked are blocked. The reason I would do it before user acceptance, or maybe even before quality assurance, is because if you have to lock down some functionality of the operating system, you want to make sure that the application still functions as expected. In my experience, quality assurance likes to receive the application on a test server that is configured with all the security expected in production. That way, when they run their formal test plans against it, we can be pretty certain that the security is not going to break the application. Next is audits. Again, audits are not the same as risk assessments, penetration tests, or vulnerability scans. The purpose of an audit is to test outcomes and make sure they match management's expectations as specified in policy standards and guidelines. Management's expectations become what we call key controls in an audit. A key control is something that should exist. It's a condition or state that auditors expect to find based on policy and based on the procedures that we said that procedures and technology that we said we have implemented to reach those objectives. And we're going to look at a key control here in the next slide. An important point follows, and that is that auditors and security personnel should not be enemies. It should not be an adversarial relationship. It should be a partnership. Auditors are trying to keep the business out of trouble, make sure that the external auditors don't find any material deficiencies. Those are deficiencies reported to the board of directors and senior management. Security personnel are trying to keep the data secure and should be working with the business to assure continued productivity. Auditors and security people have to work together to achieve the overall goal of safely achieving business objectives. And if they're fighting with each other, there are going to be huge gaps in that effort. And finally, internal audits often only check financial issues. For example, in SOX, it's only checking the integrity of the financial information. In many cases, IT management, the security team, could ask internal audit to check further when it goes and looks at target applications. For example, internal audit in my last employer also looked at a HIPAA compliant or an application that should be HIPAA compliant whenever they do the SOX audit. And we asked them to expand it so that it also looked at confidentiality and availability issues, which they did. So this was not material to the external auditors, but it was material to us. It let security and management know and understand what gaps we might have in HIPAA compliance, so that if the federal government ever came in to do a HIPAA audit, we would be reasonably sure that we were achieving the appropriate outcomes. So here's a sample termination audit. So the key control here is that by policy, all accounts for a terminated employee should be disabled within 24 hours. So that's a key control. That's a policy specification, a standard that translates by auditors into a key control. So the auditors select a target application, or maybe they're going to go across all applications for terminations, which is quite common. So in this particular example, let's ignore number one and say that they're going to go across all applications. So they go to the authoritative source for job status, which is a human resources system, and they pull all job terminations since the last audit. Now, a terminated employee is not just one who was fired. It is any employee who has left the company for any reason. Out of that termination set, out of that termination population, they randomly select 25% test population, or a test set, subset. Now this 25% is based on a formula auditors use based on the size of the set and the risk and some other variables, which we're not going to go into in this class. The auditors then check to ensure terminations were properly managed. So they're going to go into either the target application, if we're going with the step number one, or they're going to go across all applications to determine whether or not the accounts for a specific employee were terminated. And the easiest way to do this is to take the employee, determine what role they were in, go to that role in the role-based access control, or RBOC solution, find out what applications that role has access to, and determine whether or not all the accounts were disabled. All the accounts in those applications were disabled for the employee under study. Now, auditors do not expect us to be perfect. So included in the formulas that they use, they're going to determine how many missed terminations or how many missed compliances with the key control we can have and still pass that key control. So if more than n terminations were missed, then they're going to mark the key control for the target application as failed. The value of n depends on the size of the tested population set. The larger the test population, the more failures audit teams will accept. So again, it's all based on risk. You know, I consistently passed audits, but I never had an absolutely perfect audit. Okay, they're always going to find something. When they do find something, even though we pass the audit, we go back and we do a root cause analysis to find out why that was missed and try to prevent it from happening in the future. 9 times out of 10, the miss is caused by human error, not by intentional human act, but by error, some mistake that was made or mistaken judgment. Again, that's why one thing you need to take from this class is we never rely on human behavior as a highly reliable security control. And finally, we look at audit frequency. How often should we audit a specific application or system? Well, that depends on how the data is classified. Obviously, data that has higher classifications would get audited more often. Results of past audits. If a system consistently passes an audit, then auditors and security and IT people can work together to say, look, let's extend this out. So for example, I had a financial system that consistently passed audits, did very well, and it went from a 3-month audit to a 6-month audit, from a 3-month cycle to a 6-month cycle. And finally, there's management's appetite for risk. If management accepts a high rate of risk. Maybe they don't audit anything internally except maybe once a year just before the external auditors arrive. This is something that you should speak against, and it is without audits, we don't know whether or not we're reaching the appropriate outcomes from all the procedures, the policies, the controls that we've put in place. The only thing that actually tests outcomes as opposed to attacker paths and best practice compliance is an audit. So if the company doesn't have an internal audit team, or they don't want internal audit to be looking at IT systems on a regular basis, consider doing it yourselves. We did this on some things. We had the termination process was very, very important for both SOX and for HIPAA. So what my guys would do between audits, internal audits, and the external audits, is once a week they would pull a sample of terminations and check those against the HIPAA applications to make sure that the accounts had been appropriately disabled. We did this for about a year, and until we had done enough root cause analyses and plugged enough gaps that we consistently achieved our termination goals. So again, I'm going to tell you one more time to read all your assigned materials. And I would also like to thank you for being in this class. This will be the last time I actually speak at you. And I wish you all the success in the future. I also want to tell you that I'm always available to bounce things off of or to ask questions. I like to hear about new things that are going on. That's how I keep up to date. And we're all in IT together, and we all need to work together to help our businesses and our own careers be successful. So do never hesitate to contact me through my personal email or call me. You can also find me on Facebook and Twitter. And that's it. And again, ask any questions you may have about the team assignment or about any of the discussion questions and their responses this week in the main forum.